Welcome to this explainer. Today, we're unpacking the SASB standards for the oil and gas refining and marketing industry. We're going to jump right into it because we're exploring how massive industrial choices create these huge societal ripples that affect literally everything, from the air we breathe to the local water supply. So let's kick things off with a foundational question about the fuels we rely on every single day. Because, not all crude oil and definitely not all refineries are created equal. The choices made at the very beginning of the supply chain, they have this enormous downstream effect. It really all comes down to this core clash: raw crude inputs versus specific refined product demands. Think of it this way. If a refinery takes in heavy sour crude oil, but the market is demanding highly refined, clean-burning fuel, well, the operational complexity of that refinery just absolutely skyrockets. And that specific complexity is the engine that drives everything else we're going to measure today. Okay, here's our roadmap for the explainer. We'll hit the refining complexity equation, track the environmental footprint, manage hazardous materials, protect the human element, navigate regulations and pricing, and wrap up with why standardized metrics actually matter. All right, part one, the refining complexity equation, defining the industry. Let's get into it. Here is kind of the golden rule for this space. Operational complexity directly drives both massive capital expenditure and intense environmental consequences. A highly complex refinery needs advanced tech and just a ton of upfront capital. Why? Because it requires vastly more energy and processing steps, which means its environmental footprint expands dramatically. It's a direct trade-off. Now, you also have to look at who is actually doing the refining. You've got independent, pure-play refineries. They solely refine and market. And then you have these massive integrated entities that do the whole shebang. They drill and extract the oil too. But here's the thing. Regardless of their size, both types rely on these exact same downstream standards to manage their footprint. Moving right along to Section 2, tracking the environmental footprint, measuring the first ripples. Let's clear up some of the jargon right away. Scope 1 basically covers the direct on-site emissions. These are heavily driven by that massive energy intensity we just talked about. Processing heavy crude takes a tremendous amount of heat, which means burning fossil fuels right there on site, releasing significant quantities of carbon dioxide and methane directly into the atmosphere. But hey, it's not just global greenhouse gases we need to worry about. We really have to look at highly regulated, localized air pollutants too, things like sulfur oxides and volatile organic compounds. If a complex refinery sits right near a densely populated urban area, tracking these specific emissions isn't just a compliance exercise, it's absolutely critical for the health and safety of the surrounding community. On top of air quality, refineries gulp down massive quantities of water for cooling and processing. Again, this depends heavily on how complex the operation is, so tracking water withdrawals in regions that already have high or extremely high baseline water stress, that's a vital metric. Managing this well is just absolutely essential for avoiding community disruption and dealing with water scarcity risks. All right, Section 3, managing hazardous materials, byproducts, and legacy risks. So how do we actually measure this physical waste? Well, SASB metrics require companies to report not just the raw tonnage of hazardous waste they generate, but crucially, what percentage of it is actually reused, reclaimed, or remanufactured. And a quick fun fact here, actually, scratch that. It's an important distinction. Simply incinerating that waste to recover energy doesn't count as recycling under these standards. The ultimate goal is true circularity. We also need to look underground. Refineries and gas stations rely heavily on underground storage tanks, or USTs. Out of sight, but definitely shouldn't be out of mind, right? A single leak can cause severe groundwater contamination, creating these massive long-term remediation liabilities that can linger for years, even long after a facility is closed down. So tracking these releases is a major indicator of how well a company manages environmental risk. Which brings us to Section 4. Protecting the human element, workforce health and safety. To measure these physical risks fairly across the entire industry, we use this baseline number, 200,000. This number represents the total hours that 100 full-time workers provide in a single year. It basically acts as a standardized yardstick, the denominator for calculating workforce safety, injury, and fatality rates. It ensures we can compare safety performance apples to apples across vastly different facilities. Let's look at the real-world stakes here. A loss of primary containment, which is essentially industry speak for a spill, a leak, or an explosion, is broken down into tiers. A Tier 2 event might mean a recordable injury or a minor financial hit. But a catastrophic Tier 1 event, we're talking fatalities, massive financial damage, or even forced community evacuations. The stakes are incredibly high. To prevent those catastrophes, refineries have to track Tier 3 indicators. You might know these better as near misses. Tracking these, the "phew, that was close" moments, is a vital leading indicator. It helps management spot system flaws and operational weaknesses well before a devastating Tier 1 or Tier 2 event can actually happen. Okay, moving to Section 5, Navigating Regulations and Pricing, Integrity and Future Fuels. Because refineries sit at this critical bottleneck in the supply chain, regulators heavily scrutinize their pricing and supply decisions. Tracking monetary losses from legal proceedings tied to things like price fixing, that reveals exactly how exposed a company is to massive regulatory liabilities and legal risks. Plus, as global regulations continue to evolve, these refineries have to adapt. They're actively analyzing their capacity right now for advanced biofuels. We're talking about fuels that boast at least a 50% lower life cycle emissions profile compared to traditional gasoline. Honestly, investing in this infrastructure today is exactly how these companies are going to survive tomorrow. And finally, Section 6, Why Standardized Metrics Matter, the final takeaway. So what does this all mean? The real value lies in visibility. By systematically measuring everything from wastewater discharge to safety near misses, refineries can capture operational efficiencies that reduce their massive overhead costs. But more importantly, it minimizes their negative socio-environmental impacts. This helps them mitigate litigation risks and, ultimately, protect their social license to operate in their local communities. We're going to leave you with this final thought. As the world inevitably demands cleaner outputs and much tighter regulations, how quickly can this massive, deeply complex industry pivot its operations to meet the future? Understanding these metrics is really the very first step in watching that evolution unfold. Thanks so much for joining us on this explainer.